right, how can you write a quadratic function that fits data? All right, so if you're given 3 points, so in order to write a linear function, you need at least 2 points, because from those 2 points you can find the slope, and then you can plug in 1 point to get the b value. However, if you're going to write a quadratic function, you need at least 3 points. And it's really helpful if one of the points is your y-intercept, okay? So in this video, we're going to do only ones where you have the y-intercept. Okay, so you're given these 3 points. So here's the steps. The first step is you're going to make a chart that looks like this. So you have your 3 points, 0, 5, 2, 1, and 3, 2. Okay, so you know that a quadratic function looks like y equals ax squared plus bx plus c. So you're going to plug these in for x and y. Okay, so I plug in 5 equals a0 squared plus b times 0 plus c. And here you can see I plug in the 1 value for y, and then I plug in 2 for x, so a times 2 squared plus b times 2 plus c. And then I do the same thing here. So I plug in the y value, 2 equals a times 3 squared plus b times 3. So I plug those in, and then I go ahead and actually solve this out. So these zeros are going to cancel out, so it's going to tell you what c is. That's why it's helpful if you have the y-intercept, because you automatically know the value of c. Okay, so then if I look here, if I actually take the 2 squared, I get 1 equals 4a plus 2b plus c. And on this one, I get 9a, 2 equals 9a plus 3b plus c. All right, so I'm going to get these 3 equations based on the quadratic equation. All right, now, the next step. I know that c equals 5. Okay, so I had 3 equations. So since the first equation was c equals 5, I'm going to use substitution. I'm going to substitute it into the second equation, and that should say equation 3. So into equation 2 and equation 3, I'm going to substitute c. So I just had 1 equals 4a plus 2b, and I substitute in c equals 5. Subtract 5 from both sides, so now I have what looks like just a plain linear equation. It doesn't say x and y, it says a and b, but same thing. We know we can have different variables. Okay, over here I plug in 5. So I subtract 5 from both sides, and I end up with, again, what looks like a linear equation. Negative 3 equals 9a plus 3b. Okay, so I plugged it into the second and third equation. So now I just have a system of 2 equations. So now that I've written this, I have 2 linear equations, and I'm actually going to solve that system. So I write it here. In the pink are my 2 equations. So 4a plus 2b equals negative 4. I just move this to the other side. And 9a plus 3b equals negative 3. So now you have to reach back in your head, back where you've been storing systems of equations. And when I solve by elimination, I need to eliminate one of the terms, so I decided to eliminate b. So I multiply the top by 3, so I got 12a plus 6b equals negative 12. And I multiply the bottom equation by negative 2, which got me negative 18a minus 6b equals 6. So if you remember from elimination, the goal is to eliminate one of the variables. So I now have eliminated b. I add and get negative 6a. I add these constants, I get negative 6. Divide by negative 6, and I now know that a equals 1. Okay, so again, since I had the y-intercept, I knew right away that c equals 5, because one of the equations turned into c equals 5. Now I've used elimination to find out that a equals 1. So what am I missing? b. All right, so how am I going to get b? Well, I'm going to plug it in, of course. So the next step is to substitute what I got. I got a equals 1 into one of my equations. So I could plug it into equation 2 or 3. So I had negative 4 equals 4a plus 2b. I plug in what I got for a, which was 1. And then subtract 4 from both sides, divide by 2, and I now know that b equals negative 4. So I had c, I substituted c in to make 2 equations, I used elimination to solve for a, I plugged a in to get b. Now I know that a equals 1, b equals negative 4, and c equals 5. So all I'm going to do is plug it into the quadratic equation. Okay, so the quadratic equation looks like this. So I plug it in, 1, negative 4, and 5, and it ends up looking like x squared minus 4x plus 5, and that's my equation. All right, let's go all the way through this process one more time. I start out with 3 points. From the 3 points, step 1, use the points to create a system of equations. I take the 3 points, I plug them all in to ax squared plus bx plus c, and then I simplify, so I'm left with 3 equations. If I'm given the y-intercept, which in these examples I am, one of my equations tells me what c is. So now I have this, and then I have 2 other equations. Step 2, substitute c into both of the other equations. So now I take equation 2 and I take equation 3, and I substitute c in. So you can see here in blue, I substituted c in. Okay, now I add c to both sides, so now I have something that looks just like a linear equation, 3 equals a plus b. Over here I add 3 to both sides, and I end up with 4 equals 4a plus 2b. So now I'm left with 2 systems of equations, so who knows what I do next? Yes? Okay, great, solve the system of equations. Okay, next step. Step 3, solve the systems of equations using elimination. Now that I've plugged c in, I have 2 equations. I need to eliminate, so this time I decided that I want to eliminate a. I'll multiply the top equation by negative 4, so I got negative 4a minus 4b equals negative 12. Then the bottom one, I don't need to do anything to it. Okay, those eliminated. I got negative 2b equals negative 8, divide by negative 2. I now have b equals 4. Okay, step 4, what you're going to do, you're now going to substitute b equals 4 to get a. Okay, so I can choose either equation. I'm just going to choose a plus b equals 3 because that equation is really easy. So I do a plus 4 equals 3, subtract 4 from both sides, and I find out that a equals negative 1. So my last step here is that I'm going to plug in a, b, and c. So I plug it into the standard form of the equation. So I plug in negative 1 for a, I plug in 4 for b, and I plug in negative 3 for c. So now I know that my final equation is y equals negative x squared plus 4x minus 3. All right, so in your notes, I want you to try one on your own. So here is the last example, but I want you to try it on your own. Okay, so you can go ahead and pause the video here. If you're thinking to yourself, I don't know how to do this, that means that you need to actually go back to the beginning and watch through the 2 examples. So look at your notes, fill in any missing information, watch through it, and then come back. Because the point is that you should be able to do it on your own. Okay, so pause the video here, try it, and then come back and see if you got it correct. Welcome back. Hopefully you got it correct. Here is the final moment. Drum roll, please. And y equals negative 2x squared plus 3x plus 1. If you got it wrong, what does that mean? That means you need to go back and watch it. Because eventually, in the soon to near future, you will need to do this on your own on a test. Okay, so make sure you know how to do it on your own. Thank you much.